First thing you do when you get a paper is you read the front of your paper and see what the instructions are. So the time, first of all, is 1 hour. And it says, very importantly, it says give your answers correct to 2 decimal places unless stated otherwise. Answer all 7 questions and the total mark for the paper is 50. There's also a formula sheet. I would have a quick glance at the formula sheet and just to be aware of what is given to you, and then let's get started. Okay, so you've got your formula sheet and you've also got your normal distribution probability tables. Okay, first question is about Spearman's rank. It says the reading speeds in words per minute and the intelligence quotients, that's your IQ, of a group of 10 children was measured. The results are shown in the table below. So you've got reading speeds here, you've got your reading speeds, and then you've got their IQ as well. Now what you've got to do, it says write down in the table above the rank order for the reading speeds and IQ, and then you've got to go on and calculate Spearman's coefficient. So we've got to do all of these ranks, then you do your D, that's the difference between the ranks, and then we do D squared, because we need, for the formula, we need sigma D squared. So we need to add up all the D squareds to get there. Okay, the ranks, I've done these in descending order, so the reading speed, the best one is the highest one, so that's 1. First one, next one is 220, the next one is 190, that's my 3, the next one is 180, and that's my 4, and the next one is my 170, that's my 5, and then the next one, this one is 140 and 140 there joint, so that would have been the 6th and the 7th, so that is 6 plus the 7, they both get given the same, do 6 plus 7, divide by 2, you get 6.5 and 6.5. The next one then is 130. So we've done the 6th and the 7th really. So this is now on to the 8th. And then the 9th is 120. And the last one, the 10th one, is 110. Oh, sorry, just 100. Okay, so that's the reading speed's done. Now we're ranking. We're doing this row here and we're ranking it. So the first one, the highest intelligence was 120, so there's a 1. And the next one was 115, so it was 2. 112, it's 3. 110, it's 4. 105, it's 5. And then 100, where are we, sorry? 100 is 6. And then the next one, we've got 90, 90, 90. So that would have been 7th, 8th, and 9th. So if we just do that, 7 plus 8 plus 9 and divide by 3, as there's 3 of them, they are all going to be given rank 8. So that becomes an 8, an 8, and an 8. But they would have been the 7th, 8th, and 9th. So the last one is my 10th. Okay, we're now going to just do the differences. So what we're doing to do these differences, just do 9 minus 10, 6 minus 8, 6.5 minus 8, 10 minus 8, 5 minus 6, and so on to get all of those differences. So I've just done those. Hopefully I've done those correctly. And what I got was minus 1, minus 1.5, 2, minus 1, 0, minus 2, minus 2, 3.5, 2, and 0. And then when you squared those, minus 1 squared is 1, 1.5 squared is 2.25, that's going to be 4, that's going to be 1, that's going to be 0, that's going to be 4, that's going to be 4, 3.5 squared is 12.25, that's going to be 4, and that's going to be 0. And when we added those up, I got my sigma d squared, the total of those, to be 32.5, and my n is also 10, as there's 10 pairs of values. Spearman's rank, I think Spearman's rank is given to us, is it? It is, thankfully. Yep, a formula I find quite tricky to remember. So thankfully it's given to us. So our Spearman's rank, R is equal to 1 minus 6 times sigma d squared over n upon n squared minus 1. And then we just fill that in. You can just about see on the screen there. That's going to be 1 minus 6 times the 32.5 over, and then it's going to be 10 times 10 squared is 100 minus 1. Fire that into your calculator. I got 53 over 66. It's an exact value, and R is equal to 0.80, and that's to 2 decimal places. It says interpret your answer to part 2 only 1 mark, but I'm not too sure exactly what you would need. Sometimes it varies. It is a strong positive correlation. That does show a strong positive correlation. Whether that's enough to give you the marks, I don't know. So I would just say relate it to the real life thing that we're talking about. So we're talking about reading speeds and IQs. So generally, people who are more intelligent are quicker at reading. So I just say generally, more intelligent people read quicker. Okay, you may or may not need that to get the full mark, but I would just, for all the time it takes you to add that wee bit in, I would do it. Question 2 says, for 5 days, Morris recorded his fitness on his fitness app, the times he spent on his daily training runs. His times are listed in the table below. Calculate the standard deviation of Morris's times over the 5 days. So these are his times, so these are the x values. You want to have an x squared column as well, and then we will need to have sigma x and sigma x squared as a formula, and as well there's 1, 2, 3, 4, 5 days, so n is equal to 5. The formula for standard deviation, I'll just write it down why we need this. It is sigma x squared over n minus sigma x over n. That bit is squared, and it's the square root of that whole thing. So we have a wee bit of work to do. First of all, when you add up your times column, you'll get 301. When you square these, you'll get 4624, 3136. I've done this earlier on. And then that's going to be 2025, 3844. And then total these up, you'll 18529. And then, now you've got those, it is just subbing into the formula. So 18529 divided by 10 minus 301 over 10 squared, square root of that, and I got 9.04, and that's the 2 decimal places. Next question is a Venn diagram question. It says, I'm going to leave that on that we can just about see that. Let me read it first and then I'll zoom in again. Right, 50 students asked, first of all. So I'm just going to put a wee 50 outside. So remember, that's the total is 50 of everything. Generally, what you want to do is start with all 3 and work out. So it says, and that's a bit unusual. Normally, that's not mixed, not the very first thing. But it says 5 study maths, physics, and biology. So 5 goes in the overlap for all 3. Next thing says 11 study both maths and physics. So maths and physics is this plus this. So the second number must be a 6. That's that one done. 8 study both physics and biology. So physics and biology would be this one plus this one. So this must be 3. That's one done. 12 study maths and biology. So maths and biology is going to be this one and this one. So that was 12. So that has to be a 7. Okay, that's that one done. 16 study physics in total. So I'll do a wee bit of working out. So this circle is going to be 16 minus 6 minus 5 minus 3. Which works out to be 2. The next one is 23 study biology. 23 study biology. So this one here is going to be 23 minus 3 minus 7 minus 5. And that is going to be then 23 minus 3 is going to be 20 minus 7 minus 5. That's going to be 8. Yep, that's right. And then what else do we know? 9 study none. That's going to be here. And X study only mathematics. So that's what you've got for your Venn diagram. And you know the total is 50. What you have to do then for part 2 is calculate the value of X. So the value of X, so X equals, all of those numbers add up to 50. So 50 minus all those numbers. And this is an easy question, but it's very easy to get it wrong as well. So people miss ones very often. So when you're doing it, 50 equals X equals 50 minus, and then I just go, as you would read, from right to left, and then going down, from left to right, and then going down and left to right, making sure I've got them all. So 50 is equal to 6 minus 2 minus 7 minus 5 minus 3 minus 8 minus 9. So making sure I don't miss any. So don't just do it sort of haphazardly. Have a bit of logic, a bit of an order, the way you're reading them off. And when I did that, I got my x to be 10. So my value of x was 10. Next one says, a student chosen at random does not study mathematics. Find the probability a student chosen at random does not study mathematics. How you say not mathematics, there we go. And you know what, easiest probably just to count up all the ones that don't study mathematics. Let's get rid of all these wee highlights. Maybe make life a wee bit easier for me. So I'm looking for the ones who don't study mathematics. So there's someone here who doesn't study mathematics. So 2 plus 3 plus 8 plus 9. So 2 plus 3 plus 8 plus 9, all out of 50. Fire that in, that's 22 out of 50, which of course is 11 over 25. And a student chosen at random studies physics. Find the probability the student chosen at random studies physics, given that they do not study mathematics. Okay, now you can do this in two ways. You can do this as probability physics and not mathematics, divided by the probability of not mathematics, or you could just sort of look at it and figure it out. I'm going to do it this way. So that's going to be something divided by something else. Let's see. So first thing we're doing is physics and not mathematics. Okay, physics and not mathematics. Let me get rid of my highlights again. Okay, so physics and not mathematics is going to be just these two. So it's going to be 5 out of 50. So that's just 5 out of 50. And not mathematics, we just worked out here, was in the previous part was 22 out of 50. And if you did that, you're just going to get 5 over 22. And that's your answer. Okay. Question 4. Pascal's triangle. Lovely. So we just fill in complete Pascal's triangle. So the outside ones are just going to be 1. And then underneath, 1 plus 1 gives you 2. 1 plus 2 gives you 3. 2 plus 1 gives you 3. 1 plus 3 gives you 4. 3 plus 3 gives you 6. 3 plus 1 gives you 4. 1 plus 4 gives you 5. 4 plus 6 gives you 10. 6 plus 4 gives you 10. 4 plus 1 gives you 5. Lovely. 1 mark. There we go. Write down the expansion of p plus q to the power of 5. So we're using this. So p plus q to the power of 5 is, the first term is p to the power of 5 plus 5 p to the power of 4q plus 10 p cubed q squared plus 10 p squared q cubed plus 5 p q to the 4 plus q to the 5. There we go. That seems harsh. That's a fair bit of working to do for only 1 mark, but there we go. So there's my formula. Right, I imagine we're going to use this again in the next part. Okay. Right, just so I can have this. Okay, right. We're going to use this again. It says the probability that Clara was absent from school on any day is 0.13 during a particular school week. Yep, school week, which is 5 days. What is the probability that Clara is absent on exactly 2 occasions? So really, we're using this thing because there's 5 days. So we're using this. Your probability of getting what you want, which is Clara being absent, is 0.13. So not getting her not being absent is 0.87. And we want to find the probability x equals 2. So we're looking for the one where, from above, where p, the power of p, is 2. And it's this one. So the whole thing is 10. So we're looking for 10 p squared q cubed, which is going to be 10 times 0.13 squared times 0.887 cubed. And when you did that, notice there, almost missed that, says the 4 decimal places, which is going to be 0.1113 to 4 decimal places. Next one says, calculate probability that Clara is absent at least 2 times. So that's, she's absent more than 2 times. So that would be 2, 3, 4, or 5. That's a lot to do. It's also 1 minus the probability she's absent for less than 2 times. So that's 1 minus the probability x equals 0. or x equals 1. So only two things to do. So that would be q to the power 5 and p with the 1 would be, so it's going to be this one and it's going to be this one. So it's going to be q to the power 5 and what's that say? 5p q to the power 4, which is 1 minus, and that would be 0.87 to the power 5 minus 5 times 0.13 times 0.87 to the power 4. Fire that into your calculator and you should get this to 2 decimal places. Question 5. Love this question. Really nice. Good to see this type of question on it. A wee bit different than usual. Quite often it's like a new person comes into a group and you change you have to find a new mean and a new standard deviation or whatever. This one was a wee bit different. In this one, it says that somebody's result was recorded incorrectly. So a wee bit different. Nice to see a bit of a change. At a ski jump event in Norway, the mean length of a jump for the top 15, so I'm just going to write that down first of all, n is equal to 15, was recorded as, so my x bar is equal to 108.4 metres, and a standard deviation, I'm just going to write SD, is equal to 17.2 metres. One competitor's jump was incorrectly recorded as 113 metres when it was actually 131 metres. That's the sort of mistake I would make. So get my digits around the wrong way. So first of all, what we want to use this for is find what the original sigma x was, the original total. So sorry, it says here, calculate the correct mean for these 15 jumps. So you want to find the original sigma x, so it's going to be 15 times your mean. And again, I've done this already, that was 1626. So that means the new total, or new sigma x, it's going to be the old total, take away the bad value and add in the correct value, and that takes you up to 1644. Always be your biggest critic. The old result was that total was that, the new total was this. That makes sense because we've increased, okay, it has increased. So it does make sense. That means our new mean is equal to 1644 divided by, and still 15 people, and that works out as 109.6. Okay, and again, if you look at the original mean, it was 108.4. It's one of the people's times has increased. You would expect the mean to increase by a little bit, and it has. Very good. The next part says, calculate the correct standard deviation. Now you're told in the question, the original SD was equal to 17.2. So 17.2 then is equal to the square root of sigma x squared over 15 minus, and this is my original mean. What was my original mean? There was our 108.4. So minus the 108.4 squared. Now, this is going to be a wee bit messy, but I do think this is the nicest way of doing it. So just square both sides to get rid of the square root. And we have sigma x squared over 15 minus 108.4 squared. The more I do mathematics, the less I use my calculator. Doesn't mean I don't use my calculator, but I use it well, I use it efficiently. So 17.2 squared, bring the minus 108.4 squared across. Still got my sigma squared over 15, and then we can multiply across by the 15. So 15 times 17.2 squared plus 108.4 squared is equal to sigma x squared. And then you get your sigma x squared is equal to 180,696. And that means your new sigma x squared, that was my old one. So we're going to take it, and you've got to take away your original value and add in your new value, but be very careful. You're actually taking away your original value squared and adding in your new value squared. And when you do that, you will get 185088. So that means your new standard deviation is, remember what we're doing here, sorry, let me just write this up, what we're doing, sigma x squared over n minus the mean squared. That's what we're doing here. So it is 185088 over 15. And then minus, and this is my new mean. So remember the new mean we worked out in the previous part, squared. File that into your calculator, 18.08 to 2 decimal places is your answer. Okay, the next question I think is a normal distribution question. It is indeed, lovely. So it says a length of time that a mobile phone battery will last before needing to be recharged is normally distributed with a mean. So let's just write that down. Mu is equal to 28 and your sigma is equal to 5. Calculate the probability. You may or may not have been taught this way of saying that. That means x is distributed. My mean is 28. My sigma squared down is 5 squared. You don't really need that, but that's just a nice way of saying it. But what is important, you've got this. You know that my mean mu is 28, and my sigma is 5. Calculate the probability that battery will last for more than 32 hours. So that's what we're looking to find. Now what we've got to do is convert my x value into a standardized z value. And you do that using this formula, x minus mu over sigma. So in this case, the z equals 32 minus the mu, which is 28 over 5. And that works out to be 0.8. Okay, so we really want to find the probability that z is greater than 0.8. Okay, I would definitely do a diagram. There's my normal distribution table. 0.8 is here. We want this bit, but our tables can't get this. So probability that z is greater than 0.8 is the same as 1 minus the probability that z is less than 0.8. And our table can do this. So go to your tables, and we're looking for our z value of 0.8. Sorry, I'm zooming back to the start here. There's my tables. So z is 0.8, and it's 0.80 really. So it's this thing. So what's that? 0.7881. Bear with me. So it's 1 minus 0.7881. And that works out to be 0.2119. And it said in the question, the 4 decimal places. And that's why, because we're using our normal probability tables. The next one, let me just write down again before we do anything. My mu was 28, my sigma was 5. It's still the same thing. Calculate the probability that the battery will last. So probably that the x value will last more than 21 hours. That's what we're looking for. So let's find our z value. So sorry, write the formula down again. Apologies. X minus mu over sigma. So z in this case is 21 minus 28 over sigma, which is 5. So z is equal to, that's minus 1.4. So we want to find the probability that z is greater than minus 1.4 is what we're looking for. Let's do our table, our sketch I should say. There's my curve. Minus 1.4 is here. And I want to find this shaded area. Now I can't do that, but by the nature of the normal distributed curve, by symmetry, I could fire that around. That's 1.4, and by symmetry, that is the same as the probability that z is less than 1.4. And we go to our tables, all the way back to the start, our tables. And there is 1.40, which is 0.9192. So that's all it is. So it equals 0.9192. Lovely. And again, that was the 4 decimal places. Last question. It says, Fred is going to play a tennis match. Good lad. If he wins the first set, the probability he wins the second set is 0.8. So this is him winning the first set. And winning the second set is 0.8. That means that for him to lose must be 0.2. If he does not win the first set, the probability he wins the second set is 0.4. And that's 0.6. On average, Fred wins 70% of his first set. So that's 0.7 then, and that's 0.3. So that's how we fill that in the table. It says, calculate the probability that Fred does not win the second set. So does not win the second set, it would be here or here. So it's going to be 0.7 times 0.2. So along this branch, 0.7 times 0.2 or 0.3 times 0.6. So let me just write that in. So probability, we'll say not win the second set is 0.7 times 0.2 plus 0.3 times 0.6. Now I show a wee bit of working out here. You could do that in one go in your calculator, of course, but I show a wee bit of working out. Just it might be helpful, might be useful for the next part, it might not, might never look at it again, who knows, we'll see. But just from experience, you might need to know what this probability was. You might not, or the other one, we'll see. Okay, now the next bit says, given that Fred wins the second set, calculate the probability that he did not win the first set. No idea. So I'm going to say not win the first set, not win the first, given that he wins the second. So that is the same as probability to not win the first, and wins the second, divided by the probability that he wins the second. Now, quite often, one of these things you've already done. So probability wins the second is going to be so we've sort of done the first bit. Let's look at the top line here, apologies. Not wins the first and wins the second. So let's go back to our diagram. Not wins the first, doesn't win the first, and he wins the second. So that's going to be this branch here. Okay, that's him not winning the first and winning the second. So that's going to be, here is going to be 0.3 times 0.4. And the next bit is he doesn't win, he wins a second. Now what you've done here is he doesn't, up above is not wins a second. So you could just do this as 1 minus 0.32. And then again, whatever that works out to be, that's 0.12 divided by 0.68. Fire that in, well, put that in your calculator, you get 3/17, which is 0.18 to 2 decimal places. And I think that's us done. That's a tricky enough wee question. That's the end of the paper. Go back and read your paper and make sure you haven't made any mistakes. Hopefully I haven't made too many. And that's it.